Hey everyone, and welcome! Have you ever really wondered what happens after you hit compile? There's this secret world where your code gets completely transformed, a hidden process that's frankly incredibly powerful. Today we're going to pull back that curtain and look at one of the compiler's most amazing abilities.
So I want to start with a question for you. Just look at this. Is it possible for 4 programs, each written in a totally unique way, to actually be identical? I know it sounds like a riddle, right? But it's a puzzle that gets solved millions of times a day, right inside our computers. Okay, so check this out. Here we have 4 C++ functions. They all do the exact same super simple thing, add 2 numbers. But just look at how differently they're written. You've got a standard loop, a pointer version, a while loop, and even a recursive one that calls itself over and over to get the job done. I mean, on the surface, they all look way more complex than they need to be, maybe even kind of inefficient. And yet, after the compiler works its magic, all of that complexity, all those different approaches, they all just boil down to this. One single, hyper-efficient machine instruction. That's it. All 4 of those completely unique functions become one elegant line of code.
This is the part that feels like a magic trick, doesn't it? How on earth does the compiler know that all that looping and recursion was just a very complicated way of saying, hey, add these 2 numbers? Is it some kind of psychic? Can it read your code's mind?
Well, not quite. The hero of our story isn't psychic, but it is incredibly intelligent. It's a specific part of the compiler, and it's called the optimizer. And its entire job, its whole reason for existing, is to look at the code you wrote and find the absolute best, fastest way to make it run.
The optimizer has what you could only describe as a superpower. See, it doesn't just read your code line by line. It analyzes it to understand your intent. It looks past all the syntax, past the structure, to figure out the fundamental thing you're actually trying to do.
So how does it pull this off? Well, the process is pretty brilliant when you break it down. First, the compiler reads your original code. Then, and this is the key part, it translates that code into a much simpler, more abstract form. From there, it can recognize the core pattern and then finally generate the most efficient machine code possible to get that job done.
That simpler form has a name. It's called an intermediate representation. Think of it like this. Imagine you told an expert translator, "Greetings, what's up, salutations, and how do you do?" They'd instantly know you just mean hello. The intermediate representation does the exact same thing for code. It strips away all the stylistic fluff to get to the core meaning.
And this illustrates it perfectly. On the left, you've got your complicated recursive function. But the optimizer, using its internal language, sees right through it. Its understanding is dead simple. The real goal here is just to return x plus y. All roads lead to that one simple truth.
Okay, this is all fascinating from a technical standpoint for sure, but what does this superpower actually mean for you, the programmer, on a day-to-day basis? Why does any of this matter so much?
It means everything. This is the central idea right here. Because the compiler is so good at figuring out the what, it gives us, the programmers, the freedom to focus on the how. We can write code that is clear, that reveals our intention to other humans, and we can trust that the compiler will handle all the nitty-gritty details of making it fast. And this freedom is absolutely transformative. It means we can focus our energy on writing clean, understandable code that our teammates can actually read and grasp. We can stop wasting time on those tiny manual performance tweaks, the micro-optimizations, because we know the optimizer is probably going to do a better job anyway. It lets us be better engineers and, honestly, better collaborators.
So, the most crucial point, the one thing to take away from all this is simple. Write for humans, not for the machine. Your primary audience is your future self and your colleagues. Write for clarity, and let the compiler's incredible optimizer handle the rest.
So we've seen how insanely intelligent the optimizer is at understanding our code's intent and cleaning up clumsy implementations. But this leaves us with a really fascinating final question to ponder. If the compiler is this smart, what can't it fix? What are the real boundaries of this superpower? Something to think about. Thanks for joining me for this explainer.